Hi viewer, welcome to another video of the Backpacker test set, and this video probably is the most important one you'll find on the website. This is about how to rig up a complete Backpacker test set with your fluid supply, how to hook it up to something that you want to pressure test, and how you can do a low pressure and a high pressure test. We're all going to cover that in this video. The Backpacker test set, as you see here in front of you, the core of it is the compressed air driven fluid pump. It takes its fluid from the standard 40 liter 10 gallon fluid tank. We brought this on site because we don't have any tap supply here. We brought it in 20 liter drums. Of course, if you need a lot of fluid, you can also bring a large tank, and what is most convenient is hooking the pump up to a tap supply, but unfortunately we only have the hose but no tap, so we've solved it like this. From the high pressure pump you see here, we've got a compressed air supply hose that runs to a compressor. In this case, because we're in the storage facility, we don't have a compressor here. We've got parked outside a diesel compressor that we're going to start in a bit. When bringing a full Backpacker test set with your water tanks and a mobile compressor to location, you can work totally independent of anything. That will be driving our pump, and we'll be displacing the fluid from the tank through the high pressure hose into our high pressure manifold. That's why we've got the test gauge fitted. This line is connected to our circular chart recorder. Here in the middle is a special feature you can use, you don't have to use. That is a pressure relief valve. If you over pressurize the system, this will protect your gauge and your recorder. The line that comes from the manifold and goes to the piece we're going to use in this video to pressurize, to flush first and then to pressurize. Of course, in real life situation, you don't want to be out in the open with the object you're testing. You want to create a separation by a wall or something else, and you can of course easily extend the hose and move yourself away from the object you're testing. We're not going to go into a dangerous situation. The hose we have here has got a maximum working pressure of 420 bars. And first I'm going to show you how to perform a low pressure test, as we call it, at 8 bar, 120 psi. On this hose, and the second stage, I'm going to use this recorder and this gauge, and we're going to do a 400 bar, so that being about a 6,000 psi pressure test on the hose. Bear in mind that we're still within the working pressure range of the hose, so we're not going to put anybody in jeopardy. Okie doke, I don't know if you can hear it, I just started the diesel compressor, and so we've got 100 psi 7 bar here. You need for the pump, if you want to go full pull, you need 3 cubic meters a minute, so that is about 58 standard cubic feet per minute to run the pump up to maximum speed and getting maximum capacity. The first thing, because we've hooked everything up, everything is still filled with air. We've got the intake to the pump connected to our water tank, and the first thing of course we need to do is get the air out of the fluid head of the pump. So we're opening the bleed valve on the pump itself, and to prevent it from already pushing in to the system that we've got with the manifold and the object we want to test, we close, and it's already closed, we close the isolate valve on the manifold. So when I start the pump, the fluid will be taken in from the tank, all the air will go up, and this is how we take the air out of the pump. First, I'm going to turn up the air pressure to about 2 bar, being something like 30 psi. That should be sufficient. That one is open. The valve on the tank is open, and I'm now going to start the pump and let it circulate the air out to get it fully filled, especially the fluid head. Well, I don't know if it's visible, but you can see clearly that the fluid is being pushed back into the tank, and you see the motion there. So this part is fully filled. I'm now going to close the bleed valve on the pump, so the fluid cannot go back to tank. It will, when I restart the pump, enter through this hose and go into the high pressure system, and eventually into the object that we're going to use for the pressure test. I just closed the isolate valve here. I'm now going to start the pump again, and I'll let it build up pressure up to the isolate valve on the manifold. And looking at the tiny gauge here, we're just over 100 bar. The first test we want to do here, or the first bit we want to do here, is fill our object. If you start pushing water in and there is still a lot of air in there, you're accumulating a lot of energy. If the object you're testing gives in, you will get a huge amount of energy escaping at once at the point where the part is giving in, and bits and pieces will be flying all over the place. So make sure that you fill properly before you start any pressure test, even a low pressure one. So by opening this valve and having an open connector at the end of the object that we want to pressure test, the fluid can go into the manifold, follow its way through the high pressure hose, through the connector, and into the test object. I'm now slowly going to open up the isolate valve, and you will hear the pump start to run, and that means that fluid is entering the system. You will see that we're waiting for a constant flow of fluid to come out of the open end. Once that is achieved, it means that the hose is fully filled. And if you look now at the flow that's coming out, it sort of matches the stroke the pump is making, so we should be okay. If you look at the fluid tank, we've already pushed quite a bit of fluid in there, so we should be okay. I'm now going to stop the filling process by closing the isolate valve on our manifold. To be on the safe side at this point in time, of course, you can also stop the pump. So if something would happen somewhere, by closing the air valve, it means that the pump has lost its energy, its supply of compressed air, so it will not run anymore. I'm now going to close off the end of the hose that we're going to pressure test. I'm going to wind up the clock of the recorder and take the small protector off so the recorder starts recording, and then I'm going to put 8 bar 120 psi on our hose. Taking off the open end connector and replacing it with an end connector with a needle valve that's already closed. Just wound the clock of the recorder. I'm now going to take off the small protector, replacing the pen on the circular chart, and the recorder is recording. Okay, we've just done the filling, flushing the air out, we've blocked the end of the hose. So the fluid has got nowhere to go. Now is the time to start the pressure test. What I want to show with this specific test at 8 bar, that you can sort of generate any pressure with this set, even though the pump eventually can bring you 500 bars, we can do an 8 bar test on the object. And I will slowly build up the pressure so you can see that even if you want 50 psi on something, it'll work with the standard backpacker set. The first thing I'm going to do is restart the pump. So allow the compressed air from the compressor to the air drive side of the pump, so the pump is now operational. Keeping this line on pressure up to the isolate valve. The bleed valve is closed, our recorder we just started, and this is the line going to our object that we want to pressure test. At this point, I'm slowly going to allow fluid to pass by on our isolate valve into the system. And by doing so, I've got full control over the pressure that's ending in the hose. I'm slowly going to open up the valve, and you hear that our pump is running. And you see slowly the pressure building up, and I've got full control. This is 1 bar. So we've got a 500 bar pump, and I'm putting 1 bar on the system. Now slowly going to feed, and there you have 50 psi. I can take this to the lowest pressure you like from 0 upward, and you can see that I'm in full control. There is nothing overshooting, and there is no danger of overpressurizing anything if you take it slow. Easy, easy, catchy monkey. And here we go. I promised you 8 bars, so I'm going to now take you up to the 8 bar. And you can see I can real slowly move it. And there you have 8 bar. As easy. The chart recorder should be following. I don't have a visual on that one, but I'm sure it works. So if you want something at 120 psi, you can see it is very, very simple to do so. You don't need a low pressure pump and a low pressure this and a low pressure that. You can just use your standard backpacker test set to generate like 8 bars, 120 psi. It ran on a bit, so we've got some recording. The recorder you see over there has got a 1 hour clock, meaning that the circular chart will make a full revelation in 1 hour. And so to see any reading, we're going to wait for like say 5 minutes, and then I'm coming back and I'm going to take you to how you can perform a high pressure test, and then we're going to go to 400 by just changing a few items. The only thing I'm going to change are the measuring instruments, and of course I'm going to take the small safety valve off because that will pop at that pressure, and we'll be back in a sec. Okay, I've just checked the chart recorder. We've got some reading on the chart time-wise. I'll show you the chart at the end together with the high pressure chart. I'm now going to take the pressure off. First thing I'm doing is shutting off the pump and bleeding the pressure from the pump. So this line, the return line to the tank, and this is connected. So by opening the isolate valve, I'm allowing the pressure to go the other way. So the fluid is now coming back from the object, through the hose, through the bleed valve, through the low pressure hose, and ending up in the tank. And there we are, the pressure is off. What I'm now going to do is just swap the items that are not suitable for the high pressure test. And that means I'm going to switch this recorder. For the one you see in the back, I'm going to change the gauge for the one in the back, and I'm going to blind this as we don't need a safety valve. Switching the low pressure gauge for the high pressure gauge. I'm giving it a slight tap with adjustable spanner to make sure it's leak tight. I'm going to dry it off. So the first swap. The second one, I'll take off the safety valve. I'm now going to take off the safety valve because that is there to protect your low pressure gear. Because the pump is capable of running up to maximum 500 bar, meaning that a 600 bar gauge can never be torn apart by the pump, so we don't need a safety valve, so I'm putting a blind plug on there. And the last item we're going to change is the low pressure recorder for the high pressure recorder. I'm going to retrieve the chart in a bit, and I'll first replace the small protector on the pen so it doesn't dry out. And as I've done with the low pressure recorder, wound the clock. We're going to take off the protector from the pen, flipping it back on the paper, and locking the door. And now we're ready to do the high pressure test. High pressure recorder, high pressure gauge. The remaining all stayed the same. I didn't even take it apart. We're going to start off just as we've done with the low pressure test. So I'll close the isolate valve on the manifold. I'm closing the bleed valve on the pump. And I've left the air regulator at the 2 bar. The 30 psi, and I'm now going to start the pump. And the pump is doing 100 bars. The next thing I'm going to do is exactly the same as I did with the low pressure test. I'm allowing the pressure into the system, and I'm going to run it up to the set pressure of the pump. The pump is now stalling against about 100 bar, just a little bit over. I'm going to allow that in, and then we're first going to check if it all works out, if everything is leak tight, and we're going to go up in small steps. You never want to go full pressure all of a sudden on an item. You want to build it up. If you find some trouble somewhere, you might have the chance to correct it without blowing it to pieces. Okay, I'm now going to slowly allow the pressure in. And this is the set pressure of our air-driven pump. We're now going to look over the system. Because the pump has become silent, it means that it's not displacing fluid, meaning that we're not losing large amounts of fluid. If you would be losing a drop somewhere in like say a minute, that won't affect. But if you have something really wrong somewhere, you will notice that your pump keeps running. And that means that fluid has got to come out of the system somewhere. You need to find that first before you can continue, but everything is peace and quiet. So I'm now going to increase the pressure, and I'm going to do that by putting more air supply pressure on the pump. The higher you put the air pressure, the higher your fluid pressure will become. There is, in an air-driven pump, you'll always find the balance point between the force of the air and the force of the fluid. And that is the balance point. So I'm now going to increase the air pressure on the pump, meaning that I'm going to increase the fluid pressure that it will generate. This is your pressure regulator, and I'm slowly going to increase the air pressure. And we are at about 300 bar. I promised you 400. As said, go up in steps. Check if you see a leak somewhere, fluid escaping, then you can stop, fix it before you do too much damage. But we're sort of steady, so I'm going to continue. And there you have it. We're at 400 bars. Everything looking leak tight. I don't see any fluid escaping somewhere. No, we're just over the 400, that's great. If this is an actual pressure test, you might want to take off the supply. And the funny bit is, I'm now noticing that we've got a tiny leak somewhere. If you look here, there is the quick connector at the end of the hose is failing. You notice there is, for the rest, nothing happening because I've got still the pump in action. What I'm now going to do is stop the pump, because the pump is compensating for the leak that you've got over there. Now you'll see that the pressure will start to drop very slowly. It's not a huge leak, but it's sufficient to show on the gauge, and it will show on the recorder chart. We're going to leave the system as is for a bit, and then I'll take you to the recorder chart when we've taken it off, and I'll show you that leak on paper. So we're going to wait. While we're seeing that the gauge is very slowly moving downward, we're getting a very clear reading on our chart recorder showing that we're dropping, and dropping fast. Okay, I think we've seen enough. It's very clear that we've got a leak. I'm now going to take the pressure off. I'm going to do that in the same fashion as with the low pressure test. You can also, what I haven't demonstrated because there is no hose attached and I don't want to flood the floor, but you can also use the bleed on the manifold. I'm now going to do it in the same fashion as we did it with the low pressure. As said, I'm now first going to sort of slightly put this on the squeeze, and the pump is shut off so it won't add anymore, and I'm now slowly going to bleed off the pressure, and it should be clearly visible on the gauge. I'm going to open this further, and as you can see, we're totally pressureless. Okay, we've done the test. We've seen there is a leak. If you have this set up somewhere, like on a scaffolding or in somebody's workshop, and bear in mind that everything you are allowed to hand carry is 20 kilos. If you have a lot of fluid, up to 40 liters in your tank, it will be over 40 kilos. So before completely rigging down everything, we're going to use the pump to empty out the tank, or partially empty it out so it is below the 20 kilos, and we're going to put the fluid back in the drum. To do that, I'm going to close the isolate on the manifold so the fluid cannot go into the system again. We've got our bleed valve here. I'm opening up that one and I'm taking off the return line that we fitted on the tank. Taking off. Taking off the cap, and by now the pump is still at high air pressure that we needed for the 400 bar test. Now I'm going to bring it back to 2 bar. I'm going to start the pump. I'm draining the tank, putting it back in our container, and when sufficient is out, and this is easy portable, you can take everything back, put it in the van or the truck, and you're ready. You can break up all the different items, turning them back to portable pieces. And you're ready to disassemble everything and take it back to the workshop. Okay, you've seen us perform a pressure test at low pressure, perform a test at high pressure. We've disconnected everything, and here is what you see is what is a typical backpacker test set. Manifold, your fluid tank, a recorder and gauge matching with the test pressure you want to apply, and a few high pressure hoses. The pump you see in front, as said, is the core of the unit. It is the heaviest of all the items you see here. It's 20 kilos, but it's easy portable, upstairs and downstairs. Going upstairs with one hand on the railing, and downstairs with one hand on the railing and one hand for the tool. And as you can see, this will fit even in the trunk of a normal passenger car. So you can take it anywhere, go anywhere, and one person can bring it to location where you want to test and bring it back home. I hope everything makes sense and you enjoyed us perform all the different testing. Of course, it's obvious between the low and the high pressure test you can do any pressure you like. The only thing you need is the specific recorder and test gauge. That's it. Thanks for watching. Hope you enjoyed it. See you next time. Bye.